Uniform probability. Okay? Uniform probability. Uniform probability is when each outcome has the same probability pattern. So if your spinner looks the same, if your dice has the same amount of numbers on it, things like that. And a good example I have down below. So the B does not, the will B does not have uniform probability. Okay? If I would ask you which one would you want me to spin for you, what would you say? A. Well, look at it. The you win sections are the same size as the you lose. If I look at will B, the you win sections are smaller than the you lose. So in this one, I have a higher chance of having a you lose.
So you probably get more stuff. Yeah, go big or go home.
Yeah. Honestly, this is probably how a lot of things are set up, like to gamble. Like I'm guessing a lot.
Well, actually, probably more you lose.
Probably more you lose, like a little sliver of you win. Yeah, probably. But if you were gonna play a game, like you would want this one because that has the highest chances of you winning. Uniform probability means that everything in there has the same chance of being spun. Yeah.
So we got it exactly at this like one vulnerable thing.
Yeah.
This for an iPhone, and we knew it was like stupid, so we just tried it. And we almost got it. We was gonna pop, but it didn't pop. Like we hit it and it didn't pop.
But that's how pretty much all the carnival is. You know, everything is geared for it's not very uniform. The probability of you winning like carnival games are very small. Think about it. Even like when you do the basketball ones where you shoot the basketball, like the hoop is like just a little bigger than the ball, so it's very small chance of you making that basket. I mean, everything is geared so you don't win. Your two definitions for theoretical and experimentalists next. If I can find my cursor here. All right, so theoretical probability and experimental. I'll explain both when you're done writing.
Oh,
Theoretical probability is what you did yesterday. It's exactly what you did yesterday. In theory, what should happen? Yesterday, you told me when I spun my spinner, in theory, I should land on red 4 out of 10 times. That was my chances of spinning a red, or 40% chance of spinning and landing on a red. Okay, that's what you told me yesterday. You also told me yesterday maybe rolling a 1 on dice, I had a 1 out of 6 chance. Okay, that's in theory what should happen. Today, we're adding on, okay, now the experiment. What is really happening? And you guys, we kind of started doing these sessions when we had me spin spinner. We started doing this. So that's what today is. Actually, what in theory should happen, then we actually run the experiment, what did happen. So this is how it's going to work.
we did that.
Yeah, I told you. Oh, sorry, I'll go back.
It's not.
It's fine. It's right here. So I'm going to pull up another spinner. Okay. And we're going to find theoretical and experimental, because this is what your homework is going to have you do today. It's going to have you find both things. So I want to make sure you know how to do that. Can I go to the next one as well?
Yeah, how are you gonna spin a?
Once it shows up here.
No, like
In your homework, it's going to say, in the experiment, this happens. Okay? Here's what the spinner looks like. In theory, what should have happened? But this is what the experiment had. Okay, so let me show you. This is an example. So it's going to say, in theory, what's the probability of landing on a blue? In theory, on this spinner, two-fifths. In theory, that's what should happen, right? So that's your in theory thing.
Do we have to do percents?
Not today. Then it says, in experimental, it might say, you spun blue 7 out of 10 times. Okay, well, what would the experimental probability be? 7 out of 10. Then it's going to say, okay, now compare the two. Compare the two. Well, this one was approximately 40%. This is approximately 70%. Now, is it always going to end up to be the same? This is pretty much just a guideline. This is a guideline, so you know what, this is what's supposed to happen. Is it always going to end up that way? No, but honestly, the more experiment you do, the more times you spin the spinner, the closer it's going to get to this. The more times you run an experiment, the closer it's going to get to the theoretical probability. Yeah.
Because doesn't it always even out in the end?
Eventually. I mean, it'll get close. But, I mean, for example, flip it a coin. What's my chance of me getting ahead? 50%.
Yeah.
1 out of 2. Okay? Maybe I flip my coin 10 times. I could end up ahead 3 times. I could end up heads 8 times. Okay? Just kind of what happens. But if I would spin it 100, if I would flip that 100 times, it's going to get closer. It's going to get closer and closer to being 50 out of 100. Closer and closer every time. The more, like I said, the more times you run an experiment, the closer you should get to your theoretical probability. Now, if I would just ask you, and this is what it's going to do today, it's going to ask you to compare the two. You could say, oh, well, you know, the theoretical probability is a little lower. Maybe by luck, it ended up with 70%. Or if you would have ran the experiment 4 times, it would probably would have got close to 40. That's all it needs to do once you compare it. That's it. Okay. All right, so in theory, let's do another one. Let's just actually run the experiment this time and see what happens. Okay? So we know 2 out of 5 times, so we're going to spin 5 times and see what happens. So in theory, we should spin blue 2 times when we spin our spin. Okay, so first time, green. Blue. So third time, it was, so we have 2 out of 3. Ooh, 3 out of 4. So 3 out of 5 was our experimental. Pretty close, right?
And so
That's pretty close.
how do you get the answer then? Because like I could have said like 4 out of 5 times. Or
The book is going to tell you what happened in the experiment. Like, it's not going to make you run the experiment. I'm just showing you what they did in the experiment. This is how I got this number.
You're basically just saying how far off that.
Yeah, we're just looking at and comparing the two. In theory, what should happen? What did actually happen? That's what we're looking at. And comparing what happened and what should have happened.
Are we gonna have to add them together and see what the difference is?
No. I mean, but you can tell just by looking at it. The other part of this, too, sometimes it might. Here, let me do another example of this. Let's say I ran a, okay, I have 4 cards. I have one with a circle on it. I have one with a star on it. What's another shape? Square. Triangle. Okay? These are my cards. In my experiment, no, let's just say in my experiment, I picked the triangle 7 out of 15 times. Okay, so in my experimental probability was what, Matthew? Okay, that's in my experiment. Okay, in theory, what should happen? 1 out of 4. So you might not always have the same denominator. You might not always have the same thing. That's okay, but you can still look at it and say, okay, which one is greater? Well, you know 1/4 is 25%, right? Well, this is going to be close to 50% because 8 out of 15 is a little over half. 7 out of 15 is a little under half. So you know this is close to 50%. So what was better here, or what came out higher? Your experimental came out higher than your theory. In theory, what should happen? Yeah.
So then, in our homework, what are we gonna do with the humongous penguin? takes up half of our page.
Humongous penguin.
There isn't.
Okay, so I could do an example of that, if that's what you see.
Yeah, there's a humongous penguin in our paper.
It does not take up half the page.
Crazy thing
I'm gonna let her
is, you guys both know about the penguin.
You know how that works?
Yeah.
Oh, I'm just joking, chill.
It's not a huge penguin.
Pretty big penguin.
I mean, I can lift it.
Oh,
Oh my
gosh, bro, that hurts the whole
That
thing.
is a thick penguin. Can I have this big penguin on?
All right, let me give you an example of a type of prediction. So you need to put this in your notebook. So make a prediction because this is what it asks you to do with the penguin portion. Make what's happening here?
Uh-oh.
Cancel.
We are gonna get the blue square, are we?
Are we gonna get the most friends, Dad?
Okay, making a prediction. Let's talk about pizza. Let's say 4 out of 10 people
Yeah, cut one off.
like combo pizza.
Yes, come.
Okay?
Cheese.
Okay, then it's gonna say predict the number of people who like combo
And a group of
out of
20.
380 people.
What?
Okay, so just listen. Just listen. First thing you're gonna do is you're gonna find out, first of all, kind of your probability. So how many out of so many? Well, this is gonna tell you right away. Your homework doesn't, it gives you like a chart and you gotta figure out, okay, how many people like the penguins or whatever, like the monkeys. Well, in this case, 4 out of 10. Okay? 2/5 people, 2 out of 5. Now, there's many ways to solve a problem like this. Many ways. I'm gonna show you the easiest way for what you know. You guys are not comfortable with percent, a lot of you are not. And a lot of you are not comfortable with ratios. So I'm gonna show you the easiest way to solve this problem. You're gonna, just hold on. You're gonna take this right here, your not proportion, but your probability, and you're gonna times it by 380. Yes, 380 goes on the top. You're gonna multiply across. If you can reduce first, you can reduce. If you can use reduce 5, 380. I'm not sure what it is, but that's what. 380 divided by 5 is 7, 8, 7. 35, 77.
So give me that big number.
So then 2, yeah, I think so. Oh, I think maybe
Yeah,
it's a
number
little higher. 720.
is like 720.
So 77 times 2.
Are you putting the fraction into the 380? So
This is what it looks like now. I put this as a fraction, 380 over 1.
yeah, but will the answer turn out as like an unsimplified answer?
Shouldn't, it might if you don't reduce. If you don't reduce, it will. If you don't reduce, you have to simplify at the end. So 77 times 2, 14, carry them on, 154. So approximately 154 people like combo out of 380. Okay?
Yes.
There's other ways you can do this. Another way you can do it, there's a lot of ways. You can set up proportion if you'd rather set up proportion. So if we said 2/5, 2 out of 5 people like combo. Well, if I have, what did I say? What was on top? 380. I can solve it like this. That's cross product. Still gonna get the same thing. Another way you can do it is you can make this a percent, which is 0.4, or 40%, and you can take 0.4 times 380. It's gonna give you the same thing. So there are so many ways you can solve this problem. So many. You have to figure out what works for you. I just decided to do multiplying by fractions because usually 7th graders always go to fractions. You can change it to a decimal and multiply by a decimal. You can set up a proportion and do cross products. This is the same as working with percent. There's so many ways. Okay, so let's do another one then. See which way you like the best. So let's say 3 out of 5 like country music. Out of 550, predict how many like country. Okay, so think about what you do. There's a lot of ways you could solve it. I don't even know the answer, I just made it up. So you could do
330.
You could do 3 over 5 times, what did I say that was? 550?
Yeah.
Okay, this is one way. Another way, you can take 550.
Times 0.6.
You can reduce, yeah, you can reduce first. Actually, this is really nicely, you can easily reduce that. 110 is what it would reduce to. Yeah, that's really easy. You could take this times 3/5 is 60% times 0.6. It's going to give you the same thing, so there's a lot of things you can do. But don't forget, like this is the focus of the lesson today. The focus is knowing the difference between theoretical and experimental. That's the biggest difference. That's what the biggest thing for today is. Don't let this be the takeaway. The biggest thing is knowing and how to find theoretical and experimental probability. Okay? Any questions for me? For today's homework, you're going to have to read. You're going to have to, because most of it is historical, because they have to tell you what they do for their experiments in historical. So you're going to have to read and read the directions. Don't come to me and say, well, I don't get this, we didn't read the directions yet. You have to read the directions.
Wait, will they ever say, so, will they ever say what we just did yesterday? Like,
No.
Sue, was this, or do I not know what we're all speaking?
Mm,
I don't
no,
yeah,
they're like
that's what I
before.
saw.